Alright, here we go. We're going to start with lesson 7.3, and we're probably going to be two videos for this lesson, one of them dealing with a couple terms and some similar triangles, and the second video will deal with a couple theorems. So first two terms we're going to be talking about in lesson 7.3 are arithmetic mean, which I don't think the book actually mentions, but I do want you to know it, and then geometric mean, which is what we're going to do a lot of in this lesson. So let's come back to arithmetic mean. Now, you actually probably already know how to do arithmetic mean. Arithmetic mean is just a fancy way of saying find the average, but there are actually three different types of averages. There's mean, there's median, and mode. You probably learned about those someplace in middle school. Mean is what we usually think of when we say average. We add up all the numbers, we divide by how many numbers there are, and that's our mean or our average. But another type of mean is the median. That's where you put all the numbers in order, and you pick the number in the middle. Alright, and then mode is just the number that occurs the most common. But we're going to focus on this concept of arithmetic mean. So basically, arithmetic mean, we're only going to do this for two numbers. Basically means you add, and then you divide by 2. Okay? Just add the two numbers together and divide by 2. Basically find the average of the numbers. If we want to put that in kind of symbolic notation, x plus y over 2. Alright, so I'm going to do a couple simple questions. We're just going to do maybe two quick examples. I want you to find the arithmetic mean of, let's do 12 and 30. Okay, real basic. Find the arithmetic mean of 12 and 30. So all we're going to do is add 12 and 30. We're going to divide by 2. So we're going to add and get 42 over 2. We're going to get 21. Okay, that's it. Real basic. That's the only example I'm going to do of that. We don't do a ton of it, so pretty simple. All right. Geometric mean is a little bit different. Okay, geometric mean, instead of this concept of adding, now let me go back and explain to you something real quick. The arithmetic mean of 12 and 30 is basically like saying, hey, I have 12, I have a gap, and then I have 30. And I'm going to add something, and it's going to equal this number. And then I'm going to add something that's going to equal that number. And whatever I add has to be the same thing. So if I add 5, 12 plus 5 is 17, 17 plus 5, no, that doesn't work, it's not 30. Well, 12 plus what? And so on. Well, what it ends up being is 12 plus 9. And that gives me 21. And 21 plus 9. And that gives me 30. And that's really how we're dealing with the 21. It's that I'm adding 9 each time. Right? In some other possible courses, they might say something like find 3 arithmetic means between 12 and 30. So you'd actually have 3 different kind of numbers there. 12 plus something blank, plus another thing blank, plus blank, and then finally a 30. We're just doing one, so we're just going to use this formula here, add and divide by 2. Okay, geometric mean is a little bit different. So let's say I want to go 6 blank 24. Okay, well, arithmetic mean says 6 plus 24 is 30, and 30 divided by 2 is 15. So once again, this would be an adding 9. 6 plus 9 is 15, 15 plus 9 is 24. Geometric mean, though, is a multiplication concept. Okay, so I'm going to multiply 6 by something to get a number, and I'm going to take that number times the same thing I did over here to get 24. This one works pretty easily. It's just 12. 6 times 2 is 12, and 12 times 2 is 24. Okay, but sometimes they're harder. Let's say I did something like this. 4, and then a gap, and then 12. Well, 4 times 2 is 8, 8 times 2 is 16. Okay, that's too big. 4 times 1 is 4. 4 times 1 again is 4. Well, that's definitely not going to work. 4 times 1.5, well, that's 6. 6 times 1.5 is 9. Okay, that wasn't big enough. 4 times 1.8, well, that's 7.2. 7.2 times 1.8. It's not going to give me 12, it's going to give me a decimal number. Alright, so this gets a little bit harder. So we've got to have a better way than just kind of guessing our way through the problem. So this is how it works. Geometric mean, we are going to multiply the numbers. Okay, so instead of adding the numbers like we did for arithmetic mean, we're going to multiply the numbers. And then take a square root. Back with the arithmetic mean, we added and divided by 2. Here we're going to multiply and take a square root. So let's do that with 4 and 12. So here's my square root, here's my two numbers being multiplied together. I'm going to multiply the numbers, and then I'm going to take the square root of that. So 4 times 12, we know that's 48. I'm going to take the square root of 48 without using decimals, so we do our factor tree. Well, we know 48 can go right back to 4 and 12. It's kind of easy. 4 is 2 and 2, 12 is 4 and 3, 4 is 2 and 2. So I have 4 2's and a 3. My pairs go outside. 2 times 2 is 4. 3 stays inside. So 4 root 3 is my geometric mean. Well, let's look back up here at this. So 4 root 3 is right here. Well, how do I get from 4 to 4 root 3? I multiply by root 3. 4 times root 3 is 4 root 3. And then I'm going to multiply by root 3. 4 root 3 times root 3 is really 4 root 3 times root 3 is root 9. And the square root of 9 is 3. And that gives me the 12. So if I take 4 times root 3, it gives me 4 root 3. 4 root 3 times root 3 gives me the 12. 4 root 3 is the geometric mean of 4 and 12. And that ends up happening quite a bit when we do geometric means. We often get a square root in our answer. Sometimes we will get a nice whole number, like 12 up here. But if you think about doing this problem the same way we did this problem, where we multiply and take a square root, multiplying 6 times 24 is 144, and the square root of 144 is 12. So that's how we get this 12 here in the middle. So arithmetic mean. Add, divide by 2. Looks like this. Okay, geometric mean. Multiply and take a square root. If I write that in more symbolic notation like I did the other one, it would look like that. Okay, multiply, take a square root. Here's an example of it. You need to be able to do this type of example, and I'll probably give you one of the, or two of those in class. So make sure you take notes. Make sure you have an idea of how to do this. Okay, now the other thing in this part of the lesson is we're going to look at triangles. Oops, sorry about that. All right, we're going to look at triangles and this dotted line here and what it does to these triangles. So we have a right triangle to begin with. Triangle ADC is a right triangle. This dotted line, if you remember back from a previous chapter, it starts at a vertex, it comes up to the opposite side and meets it at a right angle. It is an altitude. This altitude cuts the hypotenuse into two pieces, AB and BC. And it cuts the original big triangle into two smaller triangles. Now what's interesting about this is it creates 3 triangles, and all 3 triangles are similar to each other. And that's what you need to be able to do in this part of the lesson. Okay, so I'm going to start by showing you how to come up with those similar triangles. What I like to do is I like to draw them out. I think it makes things a whole lot easier if you draw them out. So I'm going to draw them out. I'm going to do that off here over on the right side of the paper. So what I recommend that you do is draw them all facing the same direction. So there's my big triangle with the right angle. Then I'm going to draw kind of a medium-sized version of that. And it's not quite perfect. These are similar. I know this one doesn't look similar. This is probably too long, but the idea is there. And then I'm going to draw just a little one. Okay. Then I'm going to fill in the letters. Now, if you draw them the way they're facing over here, so I draw the big one, well, kind of like I drew the big one here, but then I draw the medium one with the right angle up at the top, and I draw this little one over here with the right angle way over here somewhere, it gets harder to write out a similarity statement, which is the next thing we're going to do. So it's a whole lot easier if you draw them all kind of facing the same direction. So this one's easy to put the letters on. I already know this is D. Here's the right angle. So up here I'm going to put D. This is definitely A. And this is definitely C. That's pretty easy. This letter is easy. All right. We're talking about the medium triangle here. The right angle is definitely letter B. So I'm going to go ahead and put B right here. And then this one's easy. It's the little triangle. And the little triangle definitely has a right angle of B. So I'm going to put B right here. Now we got to figure out, well, on the medium-sized triangle, I know I have a C and a D here and here. I just don't quite know where they go. All right, and on the the little triangle, I have an A and a D. And so I have an A and a D, and I just don't quite know where they go. So let me kind of show you the easiest way to do that. I'm going to come back over here. I'm going to put one mark right here. And then I'm going to put 2 marks up here. We're going to use those marks to help us out. So when I'm doing this medium-sized triangle, that's this one right here, this one mark has to be in the same spot as this mark up here. Okay, one mark, one mark. So that one mark has to be right there. Okay, up here, this one's got 2 marks. That's going to go up here. Well, this 2 mark angle isn't part of this triangle, so I'm not going to bother putting anything here. But I have marks. I have an angle here. I have an angle here. If we think back to chapter 6, angle, similarity postulate tells me these 2 triangles are similar. Now all I got to do is figure out which letter belongs here. Well, it's pretty obvious. It's the one with 1 mark. So it's got to be letter C right here. Okay, well what's this? It's the leftover letter. So in this triangle, I already used the B, I already used the C, so this leftover letter, D, ends up right here. Okay, now in the little triangle, okay, I have the right angle mark, I already got that, but I have this with 2 marks. So I'm going to go up here, 2 marks is up at the top left, so I'm going to put it up at the top left, same spot. And which letter is it? It's A. A is a part of this little triangle, so A is going to go up here. Now I can't put any marks down here. This triangle doesn't have, this isn't part of that triangle, so it doesn't have 1 mark, but that's fine. Well, what letter is it? Well, I had B, A, and D. I already used B and A, so it must be D. Now this triangle is similar to this triangle. Once again, angle, angle. Well, if the first triangle is similar to the second triangle, the first triangle is similar to the third triangle, by transitivity, the second and third triangles are similar to each other. So we can say all 3 triangles are similar. So let's write a similarity statement. Triangle ADC. So I just started up here at the top and I went ADC. Is similar to triangle. All you have to do now is follow the same order. So if I went ADC, I need to do DBC. And then down here I'm going to do the same order in ABD. These 3 triangles are all similar, and this order is important. Now, you might have done the first one differently. Maybe you did CAD. Then you'd have to do CDB, and then DAB. Okay, just do the same order, follow the same pattern. If you did CDA, CBD, DBA, that would be fine as well. And now we're going to use this to set up a proportion, and later on we're going to work on maybe solving some of these proportions. So let me zoom in a little bit here so you can see it a little bit better. Going the wrong way on you there. Alright, so how do we set this up? Okay, first thing I do is I look for a triangle that has both of these segments in it, AB and BD. That doesn't have it. That's got BD, but there's no AB. Here we go. AB, right there, and BD, right there. Okay, AB is the first 2 letters, BD is the last 2. Now DC, it's in the denominator, just like BD was, so I have to find DC in the same spot. Well, it's the second and third. So I look here, there's no DC there, there's no DC, there it is. So I'm going to underline that, I'm going to do it the same way I did here, so kind of a little farther down below. Now all I have to do is match it up. So here, it was the first 2 letters, so here I'm going to come over to the first 2 letters, right there. Okay, make that a little darker so you can see what we're talking about. Alright, so that's the missing piece. So AD would be the missing part of that. Okay, so it makes sense. AB, first 2 letters, over BD, second and third letters, over equals, AD, first 2 letters, over DC, second and third letters. So we're using the first triangle and the last triangle. In this case, we didn't use this triangle at all. In other ones, we will use that triangle. So let me give you an example of that. Alright, so here we go. Got this triangle. Zoom out a little bit. So that we can draw all 3 of them. So I got P, Q, R, and S. So I'm going to draw the big triangle. I'm going to put the right angle in it. I'm going to draw kind of a medium-sized triangle. I'm going to put the right angle in it. I'm going to draw kind of a small triangle. Although the medium and small one are almost the exact same in this picture, which actually makes it a little more complicated. All right, later on we're going to come solve this as well. So if you see that down here, don't worry about it yet. All right, let's just focus on getting these letters correct. So P, S, and R. That's easy. P, S, and R. P, S, R. Okay, Q is the right angle. So Q, that makes sense here. Q also makes sense down here. Okay, I'm going to go back and I'm going to put my 1 mark, my 2 marks. On that triangle, that's 1 mark and 2 marks. Now I'm going to focus on this triangle right here. It's got a 1 mark in it, so I'm going to put that 1 mark right down here. And what's the 1 mark? Well, it's R. So Q, R, what letter is missing? It must be the S, so S is going to go right here. Alright, now this triangle up here, this top one, it's got 2 marks in it. So I got to come over here and put 2 marks. Put it in the same spot as these 2 marks. That means it's going here, not down here. Make sure you put it up here. 2 marks. Well, what letter has 2 marks? It's letter P, so this must be P. So this triangle has a Q and a P and an S. I've already used the Q. I've already used the P. It must be an S over here. Okay, so now we can name our similar triangles. So, starting with the first triangle, maybe someone does SRP. Okay, so SRP is similar to, well, if we went SRP, we need to do QRS. And if we did SRP and QRS, then we need to do QSP. Right? And once again, you might have done it a little bit differently. Maybe you did PSR, SQR, PQS, that's fine, or SPR, SQR, QPS. That would be fine. Now, let me zoom in on this section a little bit here so that we can solve this this fraction. So SR over QR. That's got an SR, but there's no QR. Here's an SR. Remember, the order of a segment doesn't matter, so SR over QR. All right, now PR has to be in the same spot as SR. So it's got to be the last 2 letters. Hey, there it is, PR. Once again, the order doesn't matter on a segment. Well, what's missing then? Well, I had the first and second, so I must need the first and second. So right there. Ends up being SR. Now, they're the same. That's actually okay. All right. This is going to come back to be important later on. All right. Let's look at a third one. So, I want you to, I'm going to pause, actually you're going to pause the video, you're going to copy this down, and I want you to draw out all 3 triangles. It's facing a little bit different, but that's fine. When you start drawing them out, just draw your first big one, same way as the original. So just draw it like this. And draw your medium and draw your small, and then I want you to write your statement of similarity. What do I mean by statement of similarity? I mean this thing right here. Okay, statement of similarity. And then we're going to solve this. Okay, so copy this down, pause the video, draw out your 3 triangles, write your statement of similarity, and then we'll come back to this right here, so you can copy that down as well, and I want you to figure out what's missing right here. So I'm going to give you however many minutes you need, you pause it, and come back when you're done. All right, I'm going to wait about 15 seconds here so you can pause it, and now I'm going to start doing it. Alright, by now you should have drawn out your 3 triangles. You should have written your similarity statement. You should have tried to figure this out. If you haven't done that yet, stop, pause it, seriously, do the work yourself. Now I'm going to show you what you should have done. Alright, so got my big triangle. I'm going to draw kind of a medium-sized triangle. Looks almost the exact same size, but that's fine. Then I've got a really smaller triangle. These don't have to be perfect. Alright, let me zoom out just a little bit. Okay, which way am I going here? There we go. Okay, so, alright, big triangle. I know X is the right angle. I know Y is up here at the top right. I know W is down here at the top, or the bottom left. On this medium triangle, that's this one right here, the X and the Z and the Y. Z is definitely the right angle. On this little triangle with the X and the Z and the W, Z is definitely the right angle. I'm going to put 1 mark. I'm going to put 2 marks. I come over here and match it with 1 and with 2. Okay, so when I'm working on the XYZ triangle, it has 1 mark, so I put 1 mark in the same spot. It's got to be the same letter, so that's Y. So X and Z and Y, I already used Z and Y, it's got to be X. Okay, little triangle, X and Z and W, hey, it's got 2 marks. Put it in the same spot, so 2 marks right down here. Got to be the W. Okay, X and Z and W. I've already used Z and W, so that's got to be X. Now when you look at this angle X is not the big original X. It's just this tiny little X right here, from here to here. And this X right here is not the original X. It's this kind of slightly bigger thing, but it's not the right angle. It just goes from here to here. Okay? Alright, now write out your similarity statement. You should have already done this. But there's a bunch of different ways you can do it as long as you stay consistent. So I'm going to go X, Y, W. X, y, w is similar to, staying consistent, z, y, x. Staying consistent, z, x, w. Alright, now, if you did a little bit different, that's okay. Let's say you went w, x, y. Then you need to do x, z, y, w, z, x. Maybe you did x, w, y. ZXY, ZWX, that's fine, just stay consistent. Now let's figure out what's missing right here. So I have WZ and XZ, so I look over here. I don't have WZ and XZ. I don't have WZ and XZ. Ah, I do have WZ and XZ. So my WZ is first and last. My XZ is first and second. Alright, ZY needs to be in the same spot as XZ. So, yeah, right there, ZY. Here it would be XY. So it's definitely got to be ZY right here. So ZY right there. So what's missing? The first and the last. So ZX. Order doesn't matter. So if you wrote this as XZ, you're fine. Hey, look, it's the same thing. XZ. That does happen sometimes. We're going to look at that in the second video. Okay, so from this video, you need to know how to do arithmetic mean. Okay, where did I put that one? Arithmetic mean, add, and divide by 2. Okay, very simple. Geometric mean, multiply and take a square root. And then the other thing you need to know how to do in this lesson is to take a triangle with an altitude, separate it into 3 triangles, write a similarity statement, and solve for a missing piece of a proportion. If you can do that, you're good with the first half of the lesson.